we're going to be doing a demo of our Navic platform, and I'll walk you through what is Navic and what are all the use cases that come under it, and so on and so forth. And we'll do also a live version of the demo as well. So we're Aira Technologies. I'm sure you have heard of us, or if you haven't, we develop software to improve the efficiency of network operators and networks in general. Broadly, we have two kinds of software that we write. One is software that's low latency software that needs to run at the edge or on the DU itself. We call that DU software, mainly targeted towards improving spectral efficiency. But we also write a lot of software that's near real time, that improves the operational efficiency, like energy efficiency and code generation and so on. That class of software capabilities, we are branding it as the Navic product or the Navic suite. And it will have many use cases. We have already kind of identified 5 use cases that we are working on, and there are more getting added as we start talking with operators. Today, so the use cases are observe, analyze, anomaly detection, root cause analysis, energy management, and application builder. We'll be demoing observe, analyze, and application builder today, but these are all fairly self-explanatory as to what the other use cases are. You may get a glimpse of what anomaly detection is doing and root cause analysis is doing as well in the observe, analyze use case. Okay, so let's start with observe, analyze. One clarification I always wanted to make is this is not trying to replace an RF expert. AI or Gen AI is nowhere close to being able to do that. So we don't want RF expert to be an antagonistic partner with the software. This is just a tool. It's a helper, and it's helping RF expert focus on, like Sinan mentioned, focus on the problems that are supposed to be solved quicker and get them to solve that problem quicker by presenting all the data easily and quickly. So this is the platform, and you can see today you can see a command interface, which is where you'll do observe, analyze. You can see app builder, and this is where other use cases would also get added: anomaly detection, root cause analysis, zero touch provisioning. There's a few others that we are working on. So let's go to the command interface, and I'll jump into the demo and then talk about what's the data infrastructure and the Gen AI infrastructure, all that behind, because I wanted you guys to get a sense of what is it that I'm talking about. So assume that this is connected to the databases or data streams of a network, and I'm going to ask a simple question: plot the bandwidth utilization of the sites. Use I always make a bunch of typos. That's okay. So I'm just asking a very high-level question. I want to understand how much bandwidth is being utilized by each site, and it's going to go through a series of reasoning steps. First of which is to understand what is it that I'm trying to do and map those, like map bandwidth to the right parameter and stuff like that. So it's reasoning it, and it's saying bandwidth is mapping to PRB utilization, and I'll go into details of how exactly that's happening. And then it's writing code, it's retrieving the data, it's writing code, running that code on the database, and generating a plot of the PRB utilization of different sites as a function of time. And you can do simple things like you can add this to dashboard, and then it'll be there in the dashboard. So the next time you come in, you don't have to ask the same question again, and so on and so forth. This is stuff that we had showcased, similar stuff that we had showcased under the brand name of RAN-GPT, which is now getting folded into Navic. But let's go further. One of the things we always talked about is a conversational interface. It's an interactive, iterative interface. So I'm going to ask something. Let's see. We've been surprised by how this worked, but let's see if it works this time. So I'm going to ask, what's going on? If you remember the thing, one of the things had like this high utilization curve. I'm going to ask a very open-ended question. What's going on? Why is the PRB utilization spiking for site S2? And let's see what it says. Previously, we've been surprised how it's able to do certain things. Okay, so it's saying to understand why that's happening, I want to plot the PRB utilization and the mean connections over time. Note, I never asked for mean connection. I didn't say plot it. I didn't say explicitly correlate it. I'm just saying something seems to be odd. Can you help me? And it's able to correlate certain things, and it's able to give me an explanation as to why. It's saying, indicates there's a correlation between these two. When the connections increase, there's a corresponding increase, suggesting that it's likely due to this. You're getting towards, this is without an explicit anomaly detection module activated. It's not yet been activated. Root cause analysis module isn't there yet. How is it doing that? How is it able to get a sense of what to look for and so on? That is happening because of the way we have built this. This is not a simple RAG-based system. It's an agentic system. Even agentic system has become kind of de rigueur in the space. We have, each box here is a call to an LLM. So it's not a single call, there's a bunch of calls. Every user prompt is getting kind of progressively enhanced with other information and data.
What's your context window size? What's the max?
We use Llama 70B in the backend, so I don't remember the.
128,000.
Yeah, so that's the context window size. We haven't ever tested that context window because we are very kind of.
We can tell you that we are running into it now.
Interesting.
And when you hit the limit, hallucination.
Yeah. Yeah, so we have been very kind of intentional about breaking down.
It's just because, people like RAD engineers here, they have very complex things and their performance queries and things go a lot and those conversations, the short-term memory limits get hit.
Makes sense. So the different color here, that box, that's also a call to an LLM, but it's our own LLM. This is something that we have fine-tuned to telco data. So that's one of the reasons it's able to understand that, hey, these things, not every KPI is living in its isolation. There are correlations. That's how it's able to go look for other correlations and give us. It's also able to use other tools. There's dependency graphs and evolution engines, so that the goal for us is ultimately to not just have a Gen AI engine, but have a comprehensive way of making Gen AI access other traditional AI tools that, like many of you guys have talked about, have existed for decades in the industry, and they are well trusted by now. So how can Gen AI interact with those tools, get information, and then use its reasoning ability and coding ability to come up with something really impactful? So that's how we are thinking about Navic. And that kind of becomes the core logic of our module. And then that core logic, as I was promising, I'll get into the architecture, how is it set up. That core logic becomes part of our overall software suite or software block, which then interacts with the network via an SMO. And we install a small gateway app. That's how we get northbound, southbound access to actual data. And then we are either able to bring our own LLM, all the LLM calls, we are able to come in with our own Llama-based setup so that it becomes fully on-prem and air-gapped. Or if operators have existing tie-ups with other LLMs like Bedrock or OpenAI, we are able to use those calls as well. So it really, because we understand that every operator has their own kind of sensitivities in terms of choice of LLMs, we have built the entire system agnostic to the actual LLM being used. So that's the architecture. Now let's get back to that problem that if you recall, going back, this is how it looked, right? There is one site which is experiencing high PRB utilization caused by users coming into that network. So how do we solve that? This way to solve it is to write an automation. That's not really getting displayed the way I want it to, but think that imagine that there's a stadium in the middle, and there's a distributed antenna system, which as the number of users increase, what's happening today is that when that distributed antenna system gets turned on, it's kind of interfering with the other neighbors who are also covering that stadium, and that's causing a drop in the UE throughput and increase in PRB utilization. The way to solve that is to detect this increase scenario and tilt down the neighbors so that they don't become interfering. None of that animation is showing up, unfortunately, but the goal is that when you detect it, you down tilt the neighbors so that the DAS is able to take care of it and your interference has gone down, your UE throughput has gone up. And you also detect the end of the event so that when the event ends, you switch off the DAS, you up tilt your neighbors, and you're back to normal. So that's a routine that you may want to build, but then building that in a realistic network takes a long time. Somebody has to write the algorithm, somebody has to come up with the logic, then hand it over to the coding group, then they have to code it, test it. By the time it gets implemented, timelines vary, but it's months. It's not weeks, it's not days, it's months before that thing gets deployed. So how can Aira help and how can Navic help in that? Going back now to the rest of the demo. That's where our second use case, application builder, comes in. We have kind of an example of that, where the goal is to provide the RF expert or RF engineer kind of a location where they can define a routine. So this is kind of a routine builder area where you can drag and drop different elements of a flowchart. You can have iterators, you can have condition blocks. These are condition blocks where you're checking for a condition. Then depending on the value of the condition, you can have process blocks where you're doing certain things. So for example, here, and I can specify each of those blocks using natural language. So I have specified that condition where within that I'm checking for whether there is an interference scenario, and I've defined that by, again, just saying what I mean by interference. And is this throughput below that? Is this other metric above that? And if any one of those conditions is satisfied, declare that it's an interference scenario. And once it's interference scenario, do something, go and kind of down tilt the neighbors. That could be the next thing that I say. So here I'm going to say down tilt the neighbors. So you can define, and the goal is for application builder is to, it's a tool to design, develop, test, and deploy. So it's a one-stop shop to do all that. So this is not going to be developed in one day. You'll develop this, share it with your colleagues, they can comment on it, you can modify, so it becomes what today probably happens on slides or Word. You can use this as a, go ahead.
So the premise of this is, I'm hoping that you're not just asking it to make a change, but you're saying make a change, revalidate it, check if the condition still applies.
Yes.
If it applies,
yeah.
Keep making changes, keep making adjustments until the condition is no longer applicable.
Yeah.
If that is happening in real time or near real time, are you drawing a parallel between this and how the VIC is supposed to work?
No, so good question. What we are saying is that I'm just building a story where you used kind of your observe, analyze to detect that there are certain things happening, and to detect those things automatically and programmatically solve for it, you have conceptualized an RAP. Now the problem is, how do you build that RAP? And we are saying we have built a tool for you to build those RAPs. Once those RAPs are built, they have to be deployed in a standard SMO. This is a tool or a RIC. So this is a tool to build those RAPs quickly. Does that make sense, Abbas? Right? So you can conceptualize your routine, collaborate with the rest of your team, define exactly what your routine needs to be, what are the parameters and KPIs you want to check, what are the positive conditions and negative conditions you want to check, how often, all of that you can define here. And once you have defined it using conversational intent-based language, then you go to the next phase where you code it up. This is where there will be big operational efficiency, where the goal is traditionally to develop something so large, it's it's a multi-dimensional thing because you have objectives. Each block has 4 or 5 objectives, and these blocks are kind of combined in a very visual way. So you are asking an LLM to not just interpret the objectives, but also write code that kind of respects the way all these objectives are tying up. And that's what we have done behind the scenes, is to allow an LLM to read a flowchart, read the individual objectives, and map it to code.
I guess part of the question is, when you say downkill the neighbors, is that a node state, or is there some other application that you have that wants to figure out
What the neighbors are, how do you define neighbors?
what is the downkill, or is
Yes.
there one value for downkill, or depending on the loading and other things,
Yeah,
you come with an downkill?
that's a good question. So there'll be config parameters that will allow every R app should be tunable, right? So the thresholds, for example, for on UE throughput or interference, how do you define interference? You don't want to develop a new app every time you want to change that threshold. So there will be certain aspects we'll be exposing as tunable parameters, including how do you define neighbors? Is there a specific ANR definition? How are you going to define your
I
neighbors?
see it as a concept because then to his question, you then also have to see what's happening with those neighbors. You can't just change a network aspect on one side to cater to the needs of something else without knowing what's happening to them.
That's exactly what we
That's
expect.
my premise point is.
Exactly. So the RF expert who's defining this routine, so we're not selling the routine. We're not saying this is a routine, this is the R app. We are selling the tool. The expert needs to be clever enough to kind of catch those corner cases, define the routines in the right way, and collaboratively define. Maybe the first guy didn't catch exactly what you pointed out, but once he shares this routine with somebody else, the other expert, oh, but did you catch for that corner case, and so on. Once you have defined it algorithmically or conceptually, the main gain here is that it will code it for you. Right? That's exactly why I said this is not trying to replace the RF expert. The RF expert definitely needs to be in the loop. Sorry, you had a thought.
This will be the phase 2 will be connected with the observability part. So basically whatever tilt change is happening and the network is also observing it, it can resend that feedback to optimize it furthermore. So right now you're seeing it in isolation, but eventually it will be connected with the observability part as well. So it's a full loop connected. That's where the intelligence will come.
And the third component, we kind of quickly went through design, development, and the third component is testing. Once you build an R app, you need, so something wrote that code, how are you going to trust it? Right? It's LLM wrote it, how are you going to trust it? You need to pass it through certain kind of sanity tests, right? So that's where we are building this platform where it can generate scenarios, test scenarios. Here is a test scenario where it's generating synthetic data to test for the positive condition, where these are these 3 KPIs that it's looking for. And when the 3 KPIs, when the first one crosses the threshold, the tilt value got changed. And when all of them kind of did, if you remember the objectives, interference was defined as an OR condition and the lack of interference was defined as an AND condition. So we can see, is the code following all of that? And it is. So the goal is to expand this test case scenario where there'll be not just positive test cases, but negative test cases, corner case test cases, and so on. And then the next stage, which we haven't showcased here because we are still in the process of integration, is once, and also another thing is that this is code that can be exported into your Git so that other people can do peer review of your code and then have comments and modify and so on. And then once it's done, once you're happy with the code as it stands, then the next stage will kick in where you deploy it depending on your favorite SMO. It could be a CSAR file, it could be a containerized version, depending on what the RIC expects or the SMO expects. Because the business logic is the tough part. Bundling it and making it into a file that the RIC or SMO can recognize. It's not trivial work, but it can be done in a programmatic way. So that will be the next step, is to deploy it. It will either get deployed directly via this because it's connected to a gateway app. So we can either directly push an app into the SMO, or we can output a CSAR file, and the CSAR file can be loaded into the SMO by the RF expert or the team that's managing the apps. So those are the two things we wanted to showcase. The first one was, the first one was observe, analyze. The second one was application builder. And like I was saying, there's anomaly detection coming in, root cause analysis coming in. So we expect, and we are hoping that the algorithm or the platform can become greater than the sum of its parts. Right? There's going to be a lot of things that interact with each other, and so yeah, keep a lookout. We are, like Malik said, we work at startup pace. We are making changes every day. So most likely the next time we'll present this, it's going to look more complete, better, improved, all of that. Thank you. I can take maybe a couple of questions. We didn't want to make it too salesy, so maybe a couple of questions.
Maybe if you can go back to the code.
Yeah.
One thing I'm curious about is, switch to the flowchart view. So in this flowchart, there was no mention of RC mean connections or PRD utilization. Was it that Navic LLM that translated check for interference into these KPIs that need to be monitored?
No.
Or was it
It's only gonna, so it's saying average number of, yes. So the parameter name, Navic mapped it.
Okay.
So you can specify it using, just like how you did in the observe analyze, where you asked for bandwidth and it mapped it to PRB utilization. Same thing in this, you can use conversational language and say number of users connected, average downlink UE throughput.
So essentially, I wouldn't have to worry about max underscore user underscore threshold to be so specific.
Yeah.
Here, the Navic LLM can get to that specific parameter.
So two things. So Navic LLM will map average number of users to RRC connection mean. It will map average downlink UE to some other parameter. These are config thresholds that are exposed in the SMO. Those are tunable by you. What do you want the threshold to be?
Okay.
So you can change it,
I see.
right?
So these are the code variables. That
Exactly. If defined variables that can be.
That's also what you build in the library to begin with. Your large language models, you have to predefine all of this.
Exactly.
They could be a combination of 3GPP or vendor-specific counter or KPI nomenclature. So you have to define it. And then what I understand Ravi is saying is Navic will map it from what you enter as a user, layman's language, and map it to that language.
Yeah.
Those relationships have to be pre-built. So that's
So those relationships are built per SMO. Like for example, Ericsson's EIAP has a particular variable name for average number of users connected. We have pre-trained an LLM for EIAP. If you guys are using some other SON platform, we can pre-train it for that SON platform. Thankfully, there's only a handful of these. So there's a few, we know how to pre-train them on a per SMO basis. But yeah, some of the parameters are also exposed as kind of config parameters that once the RApp is deployed, you can still tune the RApp by just changing those values. So the tool is just building RApp. So it's up to the operator to understand, are they going to build two RApps, one for US market and one for, let's say, Europe? Or yeah, so it really is up to the operator if they want to build two separate RApps, or if they want to just change the thresholds for the RApp depending on the location. The tool itself is just a tool to build the RApp. How it gets deployed, how localized it should be is up to the operator. We let the operator make that decision.
Look at storage, process, compute, latency. There's so many other things that go into them to make that determination of the deployment model. Right? This is like a tool, but the deployment has so many different dependencies.
That's correct.
So yeah,
Yeah.
I don't know if you
That's
have
why
the
we
answer.
need a rack, right? We can't just trust your model as it is. It needs to work with the rack.
Yeah. So
Fine-tune.
this is fine-tuned. It's fine-tuned to a particular SMO. It will generate the tool. It will generate the RApp. Just developing an RApp today is requires two teams. It requires an RF engineering team and it requires coding team. What we are envisioning is that the dependence on the coding team is going to be lower. It's not going to be non-existent. We expect these codes to be verified by human beings ultimately, because you require 5.7s, 5.9s kind of reliability, peer review, all of that. So there's always going to be, but the hope is that our apps can become more agile. Development of our apps can become more agile. You put something, observe how it's performing, and if you want to add a parameter, change something, check for other corner cases as part of the R app. That becomes a quicker process of redeveloping the R app. Anshu?
Yes, I just have one question. Like, in the universe, when there would be many such RFs, because people would get hands on this platform, they'll have multiple RFs. So, about the conflict mitigation between the actions by all the RFs, or even like, when you talk about production network, you might need to raise a change request ticket before the RF would make a change. So, all these kind of business logics or conflict logics, you rely on the RIC SMO layer, or you have your own conflict mitigation?
Today, yes, the RIC or the SMO, just think about, even if it was a handwritten R app, all of your problems exist, right? What if two R apps conflict with each other? And that's the job of the SMO, in our opinion, to kind of conflict resolve.
Like, do you have that, or you just rely on the
We rely today on the SMO to be able to.
The policy management, if you talk about the policy, it has to rely on whatever is in there. Unless there's some special case where you have to build a policy.
Okay, guys.